TED Talk from Chapter 9, presented by Nazir Vasquez. Now, there are several functions of the circulatory system. Three main ones would include transportation, regulation, and protection. Now, transportation involves the movement of all necessary substances for cellular metabolism. Through the constant pumping of the heart, the blood flows through different vessels throughout the body while transporting various nutrients. The circulatory system allows assistance to other body systems to maintain a homeostatic balance. For instance, the urinary system, it regulates the amount of salts and waters that will enter the bloodstream, and the integumentary system, which regulates the temperature by dispersing heat from muscles. Also, there's protection. The circulatory system has a defense mechanism as it pertains to its response to injury. Once the skin is broken, it almost immediately begins to attempt to clot to keep any blood from leaving the body and any other foreign substances from entering the body. But in the event that something foreign is to enter the body, some form of infection, the white blood cells work almost immediately to fight it off. Now, looking at the components of blood, blood is made up of two basic components, plasma and formed elements. Plasma we find out is clear and straw colored, but the formed elements, which we also know as blood cells or corpuscles, includes three main types: the erythrocytes, which we know as the red blood cells, the leukocytes, which we know as the white blood cells, and the thrombocytes, which we know to be platelets. There's also a 45% to 55% split of the volume of blood being blood cells and liquid plasma respectively. Liquid plasma includes proteins like serum albumin, serum globulin, fibrinogen, and other dissolved substances. Now, what are the erythrocytes? Erythrocytes are what we normally call red blood cells. Their primary function is to transport oxygen and carbon dioxide throughout the bloodstream. They also pick up oxygen from the lungs, which is carried by hemoglobin in the erythrocytes. The iron, which is important here, the iron in hemoglobin is what gives red blood cells their color. Red blood cells live for about 4 months, or 120 days as our book describes. Hemoglobin consists of heme, which is the pigment that contains the iron, and globin, which is a protein. Now, when hemoglobin breaks down, it breaks down to a reddish brown substance that we know as bilirubin. Now, when bilirubin breaks down, a greenish substance known as biliverdin shows up. Both bilirubin and biliverdin are eliminated by the liver, stored within the gallbladder, and secreted into the small intestine to aid in the digestive process. Now, when the liver becomes diseased, these two pigments may build up in the bloodstream, causing what we know as jaundice. And jaundice is basically a yellow discoloration of the skin, causing a yellow pigment of the skin. But in embalming, because many of us are attempting to become funeral directors and embalmers, many embalmers use cosmetics or an arterial fluid, kind of like Jondaflow, which is a very popular one, to overcome the yellow pigment of the skin. Now, what are the leukocytes? Leukocytes are better known as white blood cells. Their primary function is to fight infection. Sometimes they leave the main bloodstream to fight infection in bodily tissues. Other times they may also pass through the walls of the capillaries through the process that we know as diapedesis. They're larger than red blood cells but vary in size, about on average 10 microns in diameter. Now, most leukocytes originate from the red marrow of the bones, while lymphocytes originate in the lymphatic system. Now, continue on with our leukocytes. They're divided into two main categories: granulocytes and agranulocytes. Now, granulocytes contain granules, and the white blood cells we know are called phagocytes. The agranulites lack granules, hence the A in front of the word. Um, but there are three main types of granulocytes because it's also broke down into 5 different subdivisions. There's the neutrophils, the eosinophils, and the basophils. The basophils assist in preventing the intravascular blood from clotting by producing heparin. And the A granulocytes, which include the lymphocytes and the monocytes. The lymphocytes are important in the immunity and the production of antibodies. Something important there is to realize that they are important to the production of antibodies. Now, some leukocytes are able to find foreign bodily substances in blood and in tissue, and then surround that foreign substance through phagocytosis. And these types of leukocytes are known as phagocytes. Now, what are platelets? Platelets we know as thrombocytes. Another word for platelets is thrombocytes. They're the smallest of the blood cells, and they average about 3 microns in diameter. We also find that they're also produced in the red bone marrow. They're found more frequently than leukocytes, but their primary function is to help form clots in the walls of broken blood vessels. Now, what is plasma? Plasma is the liquid part of the blood where the formed elements are suspended. And when plasma lacks clotting factors, it's called serum, and it resembles plasma in appearance. Looking more at plasma, plasma contains 92 to 95% of water and 5 to 8% of dissolved components. Now, these dissolved components, there's quite a few of them that are included, but blood proteins, which include serum albumin, which we've talked about, serum globulin, which we've also talked about, and fibrinogen, another one we've talked about. We also look at it contains the inorganic salts of sodium, potassium, calcium, and magnesium, which would include the chlorides, the bicarbonates, the phosphates, and the sulfates. Additionally, it has nutrients, which would include the carbohydrates, and among those carbohydrates, you got glucose, fats, proteins, minerals, vitamins, basic terms we've all heard. In waste, as you may have heard in the circulatory system, urea is found in plasma. Respiratory gases of oxygen, carbon dioxide, and nitrogen are also present. We also see enzymes, hormones, and antibodies additionally are present in plasma, and ingested substances. This is kind of a little different here. Ingested substances like alcohol and drugs are all found in plasma. Now, this diagram does not really do the heart much justice, as there is so much to be diagrammed in the heart for it just to be one single organ. But I'm going to do my best to try and talk about a few of these. We have here the brachiocephalic trunk. I'm going to switch to my pen here. The brachiocephalic trunk and the left common carotid artery, and also the left subclavian artery. And this big guy here is our aorta. We look additionally, as we move forward, the pulmonary artery, the pulmonary vein. We know this is the left pulmonary artery here. Additionally, here's the pulmonary trunk. I didn't label that, but there's the pulmonary trunk. The left atrium of the heart is right in here. Looking right about here, we have the aortic semilunar valve. Here we'd have the mitral or the bicuspid valve. This entire section of the heart we know to be the left ventricle. This little piece right here, which separates one ventricle from the next, one side of the heart from the next, is what we know as our intraventricular septum. This little fatty area around the heart is what we know to be the myocardium. And we have here the papillary muscles, which are these muscles within the heart. The inferior vena cava, which is right here. Our tricuspid valve is about right here. And again, this whole side of the heart pretty much is our right ventricle. And I just made a mistake by putting a little too much there, because right in here we have our chordae tendineae, which is almost like the tendons of the heart, um, basically serving the same purpose. And right up in here, you're going to have your pulmonary semilunar valve, just like you had your aortic semilunar valve here. This is your pulmonary semilunar valve. You're going to have your right atrium in here, your right pulmonary vein, and this area here is going to be your superior vena cava. Now, as I close this TED Talk, want to mention to you the reason behind this meme. I love Austin Powers, but the reason it is befitting here is because I did my best with cardiology. Right now, I'm getting ready to work on a very large service this morning. As many of you, I hope that you will get this experience to handle such sensitive and large cases. But this morning, I did my best with trying to summarize a whole lot of information into about 10 to 15 minutes. So I hope that my little explanation of cardiology, the circulatory system, and the heart has done you a bit of good. And I hope that you've learned something from it. And I wish you the very best in all of your success, and you have a wonderful, wonderful Saturday.